Assalamualaikum warahmatullahi wabarakatuh. This is Dr. Najam and I hope you all are fine in every respect. So today's our topic for the O-level physics, that is moments or turning effect of forces. So in this unit, we will explore actually what is turning effect of a force and can we quantify the turning effect of a force and how can we make an object more stable. So before starting the lecture, make sure you will do all the work in your registers or notebooks and watch the video completely. After that, like, share this video with your fellows, and if you don't subscribe the channel till yet, so kindly do subscribe. So let's start. So learning objectives are on the screen, right? So turning effect is our main topic, and after that conditions of equilibrium and stable, unstable and neutral equilibrium as per the position of equilibrium. So the first topic related about this, the forces and moment. As you observe one thing, that we are applying force on this spanner. So this spanner is used for tightening or losing the nut bolts. But by using the concept of the turning effect, we are actually moving this spanner. And remember one thing, the longer the spanner, greater the turning effect. Like if we have a smaller spanner, so definitely हमें काफी मुश्किल होगी इस चीज को घुमाने के लिए, रोटेट करने के लिए, ठीक है? So two factors that determine the turning effect. Number one, the magnitude of force जो हम इस पे लगाएंगे. Secondly, the perpendicular distance of the pull जो कि हम इसके ऊपर फोर्स लगाएंगे, उसके थ्रू जब हम डिस्टेंस को कवर करने की कोशिश करेंगे, डिस्प्लेसमेंट को कवर करने की कोशिश करेंगे. सो द बेसिक डेफिनेशन इज turning effect of a force is called moment. Okay, turning effect of a force is called a moment.
No.
Moment is also called torque. It is also called torque. And the formula for the moment is force multiplied by perpendicular distance from the point. So we can say that the moment of a force or torque is the product of the force and the perpendicular distance from the pivot to the line of action of the force. Just like this in this spanner. Okay, once we are applying force, so it exactly start to rotate, but under the limitation with the respect of perpendicular distance from the point. ठीक है? अच्छा, दूसरी चीज जो बड़ी इंपॉर्टेंट है वो है उसकी रोटेशन डायरेक्शन. Moment may be described as a clockwise or anti-clockwise. Right now, यहाँ पे जो देखो एरो राइट नीचे की तरफ मूव हमें बता रहा है, मोशन हमें इसकी डिस्क्राइब कर रहा है. Is this clockwise or anti-clockwise? So this is clockwise. ठीक है, जो हम वॉच की निडल रोटेशन के हिसाब से ऑब्जर्व करते हैं. और इसके बिल्कुल जो अपोजिट होगा वो हमारे पास होगा एंटी क्लॉकवाइज. right? Now, to increase the force applied to undoing, just like this, a nut wheel, extend the length of the spanner. You can do this by inserting over a length. So once again I'm repeating कि जितना ज़्यादा हमारे पास परपेंडिकुलर डिस्टेंस होगा उसी हिसाब से हम मिनिमम फोर्स के साथ भी काम कर सकते हैं. फॉर एग्जाम्पल द ओपनिंग ऑफ द डोर, like a person who want to open the door, so that the force needed to pull a door open depends on where it is applied. हमेशा जो डोर का हैंडल होता है वो हमेशा कॉर्नर पे होता है, और वो कॉर्नर बेसिकली हमारे पास सेंटर पॉइंट से, यानी कि जहाँ पे उसका बैलेंसिंग पॉइंट होता है या पेविट पॉइंट होता है उससे दूर होता है, और जितना ज़्यादा वो दूर होगा उतनी हमें कम फोर्स लगानी पड़ेगी चीज़ को रोटेट करने के लिए. जस्ट लाइक दिस. फॉर एग्जाम्पल इफ यू वांट टू चेक about the moment, so definitely we should know okay, what is the direction of the force and what is exactly the perpendicular distance. So the perpendicular distance is your 4 and the force applied is actually in the clockwise direction which is 5 newtons. So अगर हमें मोमेंट निकालना होगा तो हम सिंपली क्या करेंगे, फोर्स इनटू डिस्प्लेसमेंट. ओके, एंड दिस इज योर एंटी क्लॉकवाइज मोमेंट. ठीक है, एंड द यूनिट of moment is your Newton meters.
Force into force.
फोर्स आर्म बेसिकली हम उस डिस्टेंस को कहते हैं जो कि हमारे पास लग रहा होता है परपेंडिकुलरली अंडर द डायरेक्शन ऑफ द फोर्स. ठीक है, अच्छा, दैट्स वी आर टॉकिंग अबाउट द प्रिंसिपल ऑफ मोमेंट. फॉर एग्जांपल दिस बीम you observe is in a stable condition, balanced condition. That means rest of the forces acting on that particular beam is in uniform equilibrium. That means all the forces acting on the one side balances the forces on the other side, right?
Yes.
So in order to be balanced, the clockwise forces must be equal to the anti-clockwise forces. That is why we say that this beam is in a state of equilibrium. Similarly, that the principle of moment states that if an object is in equilibrium, the sum of the clockwise moments about any point must be equal to the sum of anti-clockwise moments about the same point. Just like in this example, on the left side, a weight of 20 newtons is on the beam, and it is 1 meter away from the pivot. Pivot is called the centric point, X point. And on the other side, we have 10 Newton weight with a distance of 2 meter from the center point pivot. So anti-clockwise moments, which is on the left side, that is force into displacement 20 into 1, must be equal to the clockwise moments, that is 10 into 2. So this beam is balanced according to the principle of moment, that the sum of clockwise moments must be equal to the sum of anti-clockwise moments.
In every question.
In every question, in every context. Like कि वो हमसे कोई भी एक चीज मिस करके वो पूछेगा कि बताओ कि आपके पास लेफ्ट साइड या राइट साइड के ऊपर फोर्स या उसका जो डिस्प्लेसमेंट है वो कितना आ रहा है, ठीक है। नाउ दिस इज द इम्पोर्टेंट वन, इफ we add another force, if we add another force, then what will happen with that to balance this context? So we actually combine both of the forces with their moments to calculate the actual turning effect of the one side, which must be equal and balanced with the anti-clockwise rotations. Now another example, as per the principle of moment, what is actually the hitching point? Hitching point is actually the balancing point, या उसे हम कह सकते हैं कि जहाँ से हम एक ऑब्जेक्ट को क्या करते हैं, पिवट के तौर पे यूज करते हैं, दिस पॉइंट, दैट्स कॉल्ड हिचिंग पॉइंट. So there is a concept of the center of mass. What is exactly the center of mass? The point at which the whole weight appears. ठीक है. So at the hitching point, the downward force of the trailer on a hitch is equal to the upward force of the hitch on the trailer, ताकि balance हो सके. And over here, the downward force of the rear tires on the road must be equal to the upward force of the road on the tires, and they may cancel down the effect of each other, so that but that particular body will be in equilibrium state according to the principle of moment. The rest of the forces on the one side must be balances all the other rest of the forces on the other side. So if we want to calculate the clockwise moment, so that is exactly what the point x with along with the terminal point y. तो यहाँ पे हमने इस पर डिस्टेंस को क्या किया, कैलकुलेट कर लिया. दैट वाज 6 + 3 9 meters. An anti-clockwise moment, that is 400 kilonewtons, applied on that particular trailer with the displacement perpendicularly is your 6 meters equals to 2400 kilonewtons. So whenever we applying the particular principle of moment, that is F1 d1 is equals to F2 d2, so we can easily find the downward force on the hinging point. Got it? So this
Yes.
kind of examples and these kind of numericals are very important as per your paper point of view. Now, if you want to find the y, the same methodology we will apply, because now we have total upward force as x, we have calculated in the first part, this one. So the total downward force we can easily calculate by comparing again the respective formula. So total force, that's your x plus y, and equals to total downward force, that is 400 kilonewtons, which we have calculated earlier. Okay, जो एंटी क्लॉकवाइज मूवमेंट हमने कैलकुलेट किया था. So simply mathematical formula calculation के through we can easily get the value of y as well. And this type of numericals are very important as per paper point of view.
Okay.
So we can calculate finally y, the upward force, by using the comparison. ठीक है. अच्छा जी. Now now the concept of the center of mass that we discussed, center of mass or center of gravity. that is about the upward force which is applied on this side. So definitely there are number of forces acting on the same body downwards as well. But we have a single point at which the body is balanced. Okay? Or that particular balancing point at which the whole weight of the body appears to act. This is exactly called center of gravity. ठीक है? Center of mass और center of gravity जो point है वो सिर्फ हमारे पास as per the quantity define हो रहा है. So whenever the gravitational forces are either on the side of the point G that balance this beam or ruler equalate. So that is exactly called, that point is your center of mass or center of gravity. एक ही चीज है दोनों. ठीक है?
जी.
So how do you find the center of gravity of irregular objects, for example like this? Because regular object center of gravity we can easily find. So we need a retort stand, plumb line, plumb bob, split cork, pin, and irregular shape body like this cardboard lamina. So first of all over here, allow the card swing freely from the pen, and then the card turns until its center of mass is vertically under the pen. So basically, we try to make 3 small holes near the edge of the lamina. ये जो corners हैं इसके, ठीक है? ये जो lines हमने mark की है, and then suspend the lamina freely as we do it. Hang the plumb line. ये जो bob हमें नजर आ रहा है, this one, ठीक है? From the pen in front of the lamina, and when the line is steady mean बिल्कुल straight जिसमें कोई movement ना हो, then trace that particular line on the lamina and repeat the steps 2 to 3 times. So by using this irregular measuring the regular body center of mass, you may use this particular method, this one. Center of mass and stability both are interlinked with each other. We know well one thing. अब हमारे पास यहाँ different किस्म के देखो क्या है slabs पड़े हुए. Which one is more stable, the first one or the last one?
Last one.
Why? Because it has greater surface
It
area.
is having greater, yes, volume ज़्यादा occupy कर रहा है space.
बिल्कुल. So basically center of mass and weight which is acting downwards, और जितना ज़्यादा हमारे पास इसका surface area increase होगा, center of mass, center of gravity lower होगा, that particular body is more stable. ठीक है? Similarly, जैसे जैसे हम इसको displace करते जाते हैं, due to this particular instability, ये आहिस्ते आहिस्ते क्या होगा, fall होना शुरू हो जाएगा. ठीक है? With a larger force applied, there is a more tilt, and this particular slab box goes beyond the center of gravity, so will fall over. This is called unstable situation. Unstable situation. Okay? Unstable equilibrium. The same way, if the box has a wider base and the lower center of gravity, it will be harder to tilt. So this is exactly called stable equilibrium. Stable equilibrium, right? Like this.
Yes.
If the box has a wider base and a lower center of gravity, then it will be very hard to tip over. And mostly, if the center of gravity remains at the same height, center of gravity remains at the same height, and the lines of action through its weight and contact force coincide, यानी कि दोनों एक ही पॉइंट पे लग रहे हैं, weight भी और reaction force भी, then the moment of its weight about the contact point must be 0 and it stays in the position to which it is displaced, यानी कि वो जैसा होता है वैसे ही रखा रहता है, just like circular objects, just like circular objects, क्योंकि इनका सरफेस एरिया क्या होता है, बिल्कुल नीचे टच होता है, सेंटर ऑफ ग्रेविटी डाउनवर्ड होता है, कांटेक्ट और वेट दोनों एक ही पॉइंट पे लग रहे होते हैं। तो सर्कुलर बॉडी या कोई बॉल को अगर हम रोटेट कर रहे होते हैं तो वो टिल्ट तो होती ही नहीं है, वो उसी पर्टिकुलर डायरेक्शन में क्या करती रहती है, मूव करती रहती है।
करते।
ठीक है, तो कॉन्सेप्ट ऑफ द स्टेबल, अनस्टेबल एंड न्यूट्रल इक्विलिब्रियम, आई होप यू अंडरस्टैंड।
Yes.
So this is our topic of the day. Is there any confusion?
No.
Okay, so that's enough for today. Now, after the topic of the moment and center of mass, so we just to recall the concept of the forces once again as per the revision, that we know that the forces are vector quantities which have both direction and size, and the resultant force can be calculated by adding vectors together. For example, two forces acting on one side, that's 40 newtons and 50 newtons, so collectively that particular force equals to the same 90 newtons. That means the sum of the forces along the one side added together, but on the other side both of the forces may take difference as per their resultant force, like one side is your 50, other side is a 40, so the body will move on that side where the force magnitude is greater. So that is actually the difference of the forces. So quantities such as mass and volume, which have size but no direction, so these are called scalars. And scalar quantities simply added without any particular criteria of the vectors because they don't need any direction. So how do we work out the resultant when the forces are not acting along the same line? So definitely we will use the method of the vector addition or parallelogram method or parallelogram rule. So by using that particular parallelogram rule, we use a particular method, that is, you can say a parallelogram method, or by using that we will make a parallelogram with respect to the size and the direction of the force and make a diagonal which represents the resultant in the both sides and direction. It's like this. And the component of right angles also help us to make a proper vector diagram by using head to tail rule as per the horizontal component along x-axis and vertical component along y-axis. So this is kind of a supplementary recall of the vector addition. Hopefully you understand all the topical content related about the forces. So that's enough for this topical, and we have done dynamics. And I hope you understand each and everything. So please note down all the work in your notebooks and like this video, share this video with your friends, and if you don't subscribe till yet, so do subscribe the channel as well, and also press the bell icon. You will get the notification once a new O-level physics and chemistry lecture will be uploaded on the channel. So stay connected. Thank you. This is Dr. Najam signing out. Assalamu alaikum wa rahmatullahi wa barakatuh.